A microcontroller is similar to the microprocessor that exists in our computers, but there are a few differences. The microcontroller, much like the microprocessor, has a CPU, RAM, ROM, input-output ports, and a timer. However, they all exist on one chip, whereas the microprocessor has the CPU separate from all the other components. A microcontroller also has a fixed amount of RAM, ROM, and input-output ports, whereas a microprocessor, it's left to the designer to decide on the amount of RAM, ROM, and the number of input-output ports. Another difference is the microcontroller has a lower processing power compared to the microprocessor, which means it needs less power consumption compared to the microprocessor. A microcontroller is typically 8 or 16-bit, whereas the microprocessor is typically 32 or 64 bits. In an embedded system, the microcontroller is usually connected to other components, such as sensors and actuators, and it does that through its input-output pins, I/O pins. Some of these pins are digital and some of them are analog. You can use a pin mapping diagram to tell what pins are used for what, such as the diagram in front of you. Other than the input-output pins, a microcontroller will have a power output pin, such as the VCC, which is pin 7, and a ground connection, such as pin 8, GND, and it might have other pins as well. There are several companies that make microcontrollers, each of them producing numerous types of these chips. In the open source community, the chips produced by the Atmel manufacturer are some of the most popular chips because they are used in the Arduino development boards. Because of the wide selection of microcontrollers, when designing your system, you need to look at the different specifications of different controllers to select a suitable microcontroller. For example, you can look at the frequency, which is how fast a microcontroller runs. You can also look at the voltage requirements of the microcontroller. You can also look at the power consumption of the microcontroller while it's running and the power consumption while it's in sleep mode. You can look at the analog to digital conversion options, and of course you can look at the price as well. Another criteria you should look at is the number of input-output pins. Also, RAM is important. RAM is the memory used while the system is running. ROM is another criteria. ROM is the storage capacity of the microcontroller. The data stored in ROM stays there even after the system is powered down, while the data stored in RAM gets destroyed when the system is powered off. In order for the microcontroller to carry the task it was dedicated for, it needs to be programmed. The program is usually written in a language such as C or assembly. Once we have written the code in a language such as C or assembly, we need to compile it, which means we need to convert the text into machine language. Then we need to connect the microcontroller to the PC and upload the code. Once we've uploaded the code, we test it for proper functionality and make final modification. Then we iterate through this process. We compile the code again, connect the microcontroller, upload the new code, and test it again. This is the end of this section. I hope you've enjoyed it. Thank you for watching. I'll see you next time.